Hi everybody, how are you all doing? Welcome back for video number 4 in the Learning FreeBSD series. So today we're going to talk about something called processes. And what I want you to do is go ahead and get logged in to your FreeBSD system via SSH. Again, we don't really need to use our Vert Manager to control the system anymore, especially for most of the stuff that we're going to do. Later on, we'll probably install X, and then we'll have a graphical user interface that we'll be able to work from. But at this point, we're just going to treat this like it's a server system, which for our purposes it is, and we'll just work through using SSH. So the first thing that we're going to talk about today is going to be called processes. What is a process? Well, FreeBSD, like Linux, like Mac, like Microsoft Windows, like any of these systems, what is called a multitasking operating system. That means that the operating system can do many different things all at the exact same time. And each one of those applications or programs, those are going to be called a process. Okay. And now that process is assigned a unique identifying number, and that unique identifying number is called a process ID. And you use that to identify the application itself. So you can have an application that has a PID, and then you can have sub processes for that application that will also have PIDs. Okay. And it's important to also remember that any program that runs without user input, so that's going to be something like a web server or an IRC server or whatever it is that you're going to be using the system to host for people, those are typically called daemons, or you'll also hear them referred to as demons. Okay. And it doesn't have anything to do with like biblical stuff or anything like that. They're actually using the ancient Greek word for demon, which is like an invisible spirit that just helps you. It doesn't do anything good or bad. It's just kind of the inner workings of the universe, which ergo, that's also why the FreeBSD logo is a little smiley, happy face, kind of red guy with a pitchfork and stuff. It's all uh, I guess programmer humor. But anyways, it doesn't have anything to do with anything evil or bad or anything like that. It just so happens that the ancient Greeks used that word, and so we use it within computing. So some of the skills that we're going to work on today are how do we restart, stop, or kill running processes? How do we use some of the tools to identify what processes currently exist on the system? You can use something like PS, and at that point you can see I'm running fish, and also the application PS was run, so we get to see the PID for that. If I were to, let's say, use htop, send that to the background, hit PS, you can now see htop exists. I can type kill 1242, hit enter, type PS. You'll see htop still exists, but if I type jobs foreground 1242, sent htop to the foreground, type PS, you'll see that it's dead. So essentially, what happened was we froze htop. We just essentially packaged it up and froze it and set it aside. And then we sent a command to it that said, hey, when you start running again, you're done. We're killing you. And then we unfroze htop. We brought it back to the foreground. And then that kill command took precedence. And then it was gone. Okay. And I know right now maybe you're thinking to yourself, whoa, that's a lot of stuff. How do I is this how I'm going to have to exit applications and stuff? No. What we're doing here is I'm teaching you the methods and processes required to deal with processes under FreeBSD or under Linux or Mac or so on and so forth for the purpose of in the event that you need to do troubleshooting or you need to figure out what's going on with an application, this is how you do it. Now, this is again outside of scope, but it's important that we talk about it. And this is a real story. So I had a server that was running Apache, and one of the issues that we had was every time you loaded the web page, it took 38 seconds at a bare minimum, sometimes longer to load a page. So you would type in the URL, you'd hit enter, in up to 40 seconds before you received the page, sometimes longer. All right, that's not good user interface. Long story short, the problem was we were not running opcache. Whoever set that server up did not set up opcache, but at the time I didn't know that. And so coming into this, I was under the impression that the system had been set up correctly. Opcache was running, or so I thought, right? That all of these different things had been done so that as you use that web page, you get good performance and et cetera, et cetera. And so there obviously had to be something wrong. Well, one of the first things that I did was I used what's called Gnu Debugger. And what you can do is you can take the GNU Debugger and you can connect that to a PID, and as you use the application, the GNU Debugger will actually dump information out to the screen so you can see what was going on. And what I realized very quickly was every single time you loaded a page, hundreds of megabytes worth of data was being processed through that server. Hundreds of megabytes. So if you had 5, 10 people using that web page at the exact same time, what you ended up with very quickly was the swap would fill up, the processing would max out all of the cores. It was a nightmare. It was horrible. And then as soon as we added opcache, it started the process of caching some of those steps. And once we started caching those steps, you really only needed to do all of that processing once, maybe every 15, 20, 30 minutes. And then at that point, we dropped down to something closer to 0.87 to 1.37 seconds every time you clicked, which isn't, it's not phenomenal, but it was so much faster. And it still required a whole lot of other work. But ultimately, what I'm trying to tell you is if I didn't understand how PIDs work and if I didn't understand how to identify an application and so on and so forth, I wouldn't have been able to accomplish my mission, which was troubleshooting that server so that we could get things working in a fashion in which the individuals who were working at that company could actually do their job, right? So I have logged into the system. You'll see here I'm in the FreeBSD 13 classwork. I'm going to clear my screen, and we're going to do some items here. First thing I'm going to do is I'm going to do sudo package install, and I'm going to choose htop, elinks, and tmux. Okay, I'm going to hit enter. And it's going to take a few seconds, and htop is already installed, but for the purposes of you following along, if you haven't installed htop yet, we want to make sure that it is. I'm going to choose yes, and I'm going to hit enter. And we're going to see it fetches elinks, tmux, libevent, everything should be done. So the first thing that I'm going to do is I'm going to type tmux, and I can see here that tmux works. So to get out of that, I'm going to hold control and hit B twice, hold shift, hit the 7 key, which is ampersand. It's going to say kill window fish. I'm going to say yes, and it drops me right out of that. And if I type tmux ls, you'll see no server is running. That may have been a lot, and you might be thinking to yourself, whoa, what were we doing there? Don't worry about it yet. We're going to use tmux a lot more later. Again, it's another quality of life tool that you can use. It allows you to do a lot of really cool things within your terminal that will help you be more effective. You're going to be more combat effective whenever you're using your FreeBSD system or your Linux system or whatever once you start learning tmux. Some people use an application called Screen. I don't like Screen, and I'm not going to use Screen. I like tmux, and we're going to do a little bit of graphical upgrade to tmux as well later, just to make it look a little bit prettier. As you can see down here, you can see I've got SSH and some uptime and how my processors are working and dates and times and so on and so forth. There's a lot of really cool information down here. We'll get to that later. So now that we've added those applications, the first thing that we want to do is we want to type ps, and again you're going to see fish is running, and then you're going to see that ps ran. Great. The next thing that we're going to do is we're going to type sudo ps, and you're going to see there's a lot more stuff now, right? So we can see that PS was ran, it was done as sudo, and now we can also see ttyv 1, 2, 3, 4, 5, 6, and 7. So what are those? Those are terminal emulation, is what it is. And when you're sitting at the computer, you can actually hold a combination of keys. I want to say it's Control Shift and Alt, and then you hit F5, F6, F7, and it will actually move you to different terminals. And one of the benefits there is if you lock up a terminal, you can very quickly pivot to another one. And then once you pivot to that next terminal, you can log right in and then typing HTOP, so that's Hotel Tango Oscar Papa, hit enter. We can then locate whatever that bad process is, and then we can kill it from here. So there's a lot of really cool things that we can do. So the first thing that I'm going to do is I'm going to actually quit out of HTOP. I'm going to go back in and I'm going to type in TMUX. So that's Tango, Mike, Uniform, X-Ray. Hit enter. So now we have this. I'm going to type ELINKS. So that's Echo, Lima, India, November, Kilo, Sierra. And I'm going to hit enter. And this is elinks. It says welcome to elinks. So what is this? This is a web browser that works within the terminal. So if we hit enter for OK, it'll ask us for a URL. I'm going to teach you a hint. The default search engine is actually Google. And all you need to do is type G space, so G is in golf, space, cat pictures. I'm not going to spell that. Everybody who's on the internet should know how to search for cat pictures by now. And we're going to hit enter. And so at this point, we are on Google, as you can see here up at the top. I'm going to move my mouse up here. You can see we searched cat pictures, and we can scroll down, and you can see these are all links related to cat pictures. Now, you don't see any imagery, right? And there's actually a lot of really cool things that you can do with elinks related to digital forensics, as well as internet-based criminal investigations. And we'll go over that at some point. Believe me, we've got lots of time, knock on wood, right? And we're going to go over all kinds of really cool things that you can do with elinks and you can do with these systems. I'm actually working on a video right now related to EC2 instances and how you can use an Amazon system to assist you with doing quote unquote hacker type stuff. I know that that's been requested and we are going to work on that. But elinks is just one of those tools that go in your toolbox. So with that said, I'm going to hold the control key and hit B as in Bravo. I'm going to do it a second time because if you notice, I'm nested. So I have tmux running. I hit the B again. That moves me to the other one. And then I hit C. And what that has done is it has added a tab. So you can see elinks is number 0 because all the counting starts at 0. And then fish is number 1. So at this point, I can type HTOP, so Hotel Tango Oscar Papa, hit enter, and I can hit the quick key, which is /, and I can type elinks and hit enter, and we now see elinks is highlighted right down there at the bottom. Right now, I'm going to hit Q as in Quebec lowercase, and I'm going to type PS, and we will see tmux is running, and elinks is running, and the PID for elinks is 1453. So again, htop / elinks, and you do not see anything until you look all the way over here on the left and then 1453. So that's your PID. So you see your PID and then the user that's running that PID, which is me, Aaron J. And then we have a little bit of extra information here. So we can see memory usage, we can see CPU usage and some things like that. Not necessarily super important, but sometimes you will have applications that are going to crash or they're going to use up a bunch of resources or a whole bunch of other stuff, and you need to be able to kill that application or get rid of it. And htop is one of the ways that we can do that. Now we killed, if you remember, we killed another application using the command kill. We put htop into the background and then we killed it using the PID. So here within htop, you pretty much have a graphical user. Well, It's a TUI, a text-based user interface. And so using your text-based user interface, your TUI, we can go in here and then if you press F9, you will see it will allow you to send signals. And there's a whole bunch of them. There's cancel, 0. You can use that to stop what you're doing. Sig hub, sig int, sig quit, sig ill, sig trap. So if you're familiar with computer programming and you've done anything like in C, you know sig trap. But what we are concerned about, the things that we are most concerned about here is 9, which is sig kill, and then the other one, which is 3, which is sig quit. Typically, you'll want to send a 3 if you can, which is a sig quit. That's a little bit nicer. So just send sig quit, see what it does, and if that does not work, then your next best thing is to send that sig kill, and sig kill will pretty much handle business no matter what. Like that application is done when it gets hit with that sig kill. For the purposes of one of our discussion points during the class that I'm teaching about FreeBSD right now, I ask for you to identify what process PID number 1 is. PID number 1 under a FreeBSD system is always going to be init. So sbin init is going to be the application. What I would like you to do is a little bit of research, but let's talk about sbin init FreeBSD because this also segues to handbooks. There's some really awesome information that is out there and available to you as a person who's going to be working within the FreeBSD environment. You can learn a ton from the FreeBSD handbook. So what is init? Well, when the kernel finishes booting, it's going to pass all control of the user or all control to the user process of init, which is located at sbin init, and we can see that here /sbin/init, and we can come back here, click, and we see the init utility is the last stage of the boot process. It normally runs the automatic reboot sequence, and if this succeeds, begins multi-user operations. So it's going to handle all of the multi-user operation stuff. Remember, back in the day, right? Back in the 70s and 80s, whenever you were using systems like this, the idea was a company somewhere or a educational institution or whatever would go out to a company and say, hey, sell us a computer, and they would sell this massive monster mainframe, and then 10, 15, 20 people would sit at the equivalent of a thin client and all log into the same box at the exact same time. And you would actually share resources, very similar to what we do within data centers today. I go onto an EC2 instance, and that EC2 instance is just one of many that are running off of hardware, and we kind of got to play nice, right? If I go in there and I max out my CPU usage to 100%, and I'm using 100% of the memory that's allotted to me, that actually is a drain. It taxes the system, and it's entirely possible for me to cause performance degradation uh, with my partners, the people who are using the system with me, right? Like I'm being the bad guy in the neighborhood. So there is tools that we'll talk about later, like niceness levels. You can actually go in and say, hey, I want you to run this application, but don't max everything out. Let's have a little bit of niceness here. Let's make sure that other people have access to resources. So a little bit of a segue, and I apologize for that, but init handles a lot. Okay, it's gonna have to deal with security levels. It's gonna have to deal with whether or not it's running inside of a jail. Again, this is another topic that we may touch on later, but FreeBSD is very famous for its ability to use jails in order to segregate processes for safety and security purposes. Jails, when properly configured, are an incredible tool. They are not bulletproof. there are ways to escape a jail, and there are ways to still cause harm to a system or to the individuals who are also using that system in parallel with you, even if those applications are quote unquote jailed. But in theory, using jails are they're a very powerful tool, an incredibly powerful tool, and you should definitely, at least at bare minimum, be familiar with them. So there's a ton of information here within FreeBSD in which you can learn about init. And even here you see the role of init is so critical that if it dies, the system will reboot itself automatically. So if we were to go in and we were to kill PID number 1 using sudo, so if we did sudo kill 1, this whole system would just turn off and then it would reboot itself. Okay. So those are things to keep in mind, and they are very important. So that's the information that I wanted to give you in a just very high level overview, that PID number 1 is init, and PID number 1 being init is so valuable that if PID number 1 ever dies, then the system has to reboot. So uh, here you'll see, because htop is running, we are in a process and we are looking at that process that we are running, which is htop. So we're in the htop application, and the htop application can actually see down here at the bottom that PID 1479 is assigned to htop. And I can actually hit F9, and then I can go up here to kill. So that's 9. We're going to send kill term 9, hit enter, and just type the word clear, and it's gone. That killed htop. From within htop was able to send a kill command to its own PID, and then you are out of htop, right? So I'm going to hit htop again, go back to elinks, all right, and then I'm going to hit control and then Z as in Zulu. And what that has done is that has stopped the elinks job. Now, there is a difference between a stopped job and a quit job. When a job has been stopped, we can hit PS, so Papa Sierra, hit enter, and you will see that even though elinks is no longer on our screen, elinks is running, and the PID for elinks is 1453. So if I type in FG for foreground, followed by 1453, and I hit enter, it's going to say sent job elinks to foreground. I'm going to type in G, hit G again, and then I'm just going to type in cat pictures one more time, because the issue here is the system cannot refresh the page. So this is, I think this is running curses. I didn't do my research on that before we started. It may be curses or it may be in curses, but ultimately the issue at hand is we can send elinks to the background and then we can bring it back to the foreground. But until elinks itself is in some way refreshed, aka we go to a new page, you won't be able to see it because it cannot refresh the page. It doesn't function like a window manager or a desktop environment where an application can constantly and continuously refresh an application, so you always get the latest. I don't know if you've ever been at a computer and an application has frozen and then you kind of drag your mouse across it, and that dragging of the mouse across the application causes it to become corrupted, and it maybe becomes like this very ugly mishmash of colors or something like that. That's kind of what's happening here, in that there is no way to see elinks until elinks refreshes, and we have to kind of manually make elinks refresh. So we can background it and then foreground it, but there's really no way of causing that refresh on bringing it back to the foreground. But with that said, I'm going to send it to the background again. And then PS, again, we see it. We can type JOBS, hit enter. We see elinks is running, but elinks is there. We can type EG. There are no suitable jobs. Type FG. Send elinks to the foreground. Hit Q. It's going to ask me if I really want to exit, and I can choose yes. Okay. Another thing that we can do is type PS. We see htop is there. I can do kill -9 1504. Hit enter. Jobs. There are no jobs. PS. There is no more htop. Go to here and you'll see we have killed htop, right? So using a combination of tmux so that we can very quickly create an easy way for us to be able to move back and forth. And of course, I can spawn another terminal, and then I can just log into FreeBSD, and you can see now I have two separate terminals here, both logged into FreeBSD. 100% possible. There's nothing stopping us from doing that. It just so happens that for my workflow, I much prefer to use tmux in order to keep everything inside of a single window. Because remember, I work with a lot of computers and I work with a lot of systems all at the same time. And so verbosity is incredibly important to me. Being able to know what machine I'm in at a glance at any time. Again, Threadripper, FreeBSD 13 classwork. I can hit another one. I can jump into, let's say, what's another good one? UAT, search X. Here, type in tmux. And now I'm in a system and I know what system this is. Exit out of that one, exit out. And again, I'm just moving back and forth between different computers, and I'm having to access a whole lot of technology all at the same time. So to do that using tmux is incredibly important. Being able to handle those processes, incredibly important. So to summarize what we learned today is any application is a process. That process is always going to have a PID. Process or PID number one is in it, and that's the most important one. And if it ever dies, your system's going to have to reboot. Any application that runs without user input, that's like a web server, is called a daemon. That would be the correct way to refer to that application. We learned how to background applications, foreground them, kill them. We learned how to find those applications using tools like htop. And with all of that said, processes are incredibly simple. And especially under FreeBSD, again, this is why I chose FreeBSD to be the operating system that we use for educational purposes for this class, is because it is incredibly compact. There's not a lot of stuff running, right? We're starting to get to that point where we're adding tmux, we're adding htop, we have stuff that's showing up now, but there's not a lot of stuff there, right? Just to give you an idea, I'm gonna close out of this. I'm gonna do htop, and I'm just gonna start scrolling, and I'm gonna show you. This is my current system over here on the right, and it's just going and going. I'm gonna start doing it by page, and I'm just slamming that page button and just hitting it and hitting it and hitting it. Look how many PIDs there are. On this system, my maximum PID number is 1,672. I'm at 1,792,970 and just going and going and going. And eventually we'll get to the bottom, right? Like at some point we're going to hit the bottom. Maybe. There we go. We finally did it. You see how long that took versus this? Just a little bit, right? So that's why I chose FreeBSD. There's less for you to deal with, especially on a fresh operating system. There's less things running right out of the box. There's less things for you to have to deal with. There's it's much more digestible. It's easier for you to be able to find that information, and it's a great starting point if you're going to begin that process of deep diving into an operating system. If you really want to know where your applications are coming from, how are they being ran, uh, why why do these processes exist? What do you need a PID for? How do you refer to an application? What if I'm running 3 different copies of Firefox, right? Well, each one of those different copies is going to have a PID. In addition to that, that PID can actually be used, and I teach a class on this, and at some point I will probably do this as a video. But you can actually edit in memory values for applications based off of reference to that PID, and that means I can play a game like Doom, the original Doom, and then I can load the RAM that Doom is occupying into an application that lets me search for my ammunition, my body armor, etc., and then I can edit those numbers manually. And I show that, even though it's kind of a silly example, I show that because that's the start. That's the start of showing you that these applications, they require a space in memory where they're going to write a value, and if we can go in and then we can cause effect on that value in Doom, well, yeah, we cheated at a game and we gave ourselves infinite ammo or something like that. That's cool, but think about the power related to when you start changing numbers related to other applications that are not just a game, right? What if I could change values inside of memory related to what web pages you go visit, or um, where you send money whenever you're putting in an account number related to your online banking or something like that, right? There's a lot of really neat things that when you start weaponizing them and you start thinking in that adversarial position, that adversarial mindset, it'll start getting you to that point where you'll start really thinking about, oh, okay, yeah, I'm learning the basics here, but there's an end goal to this. There's more. So with that said, thank you for. Oh yeah, we started that. Let's do kill 183 2406 kill, and then I'm gonna forward round 1832406, and now that is gone. Clear, exit, and we're done. So thank you for joining me. I really appreciate it. I hope you enjoyed this one. We have even more stuff coming in the next videos. Just stay tuned, and I will see you all next time.